How are we going for sound? Sound is good, but video is not good. Lovely, lovely way to start the session, eh? All right, just give me 1 second, guys. It's got to restart this stupid thing. By the way, I have actually put a link up there for you guys. If you click on that link, you should be able to see the questions that are up. Let me try restarting this sucker. It's funny, right? It was working like literally 2 minutes ago, and then it decides to crash on me. Just 1 second, team. Just got to restart my lovely little tablet, and we should be good to go. So yeah, as I said, if you guys want to have a look at the questions that we want to go ahead with today, you can go to the little link that I've put up the top there. Just click on that link and that should open up a OneNote document. And if you go into level 2 maths, you should be able to find the questions that we're going to work on today. Come on, work for me, man. All right. I think that's much better. Yep. Cool, guys. So apologies about the mishap, but welcome to today's session. So what we're going to be working on today is just looking at discriminants. I've got about 5 questions for you guys. These 5 questions, they generally tend to be like a combination of merit and excellence questions. So what we're going to do is just cover the basics of discriminants, and then after that we are going to go straight into some of these questions. I think the first one is an achieved question, but we've only got 5 questions today, so we're good to go. So where do we get the discriminant? Well, pretty much from the quadratic formula, as I put there. But the only real thing about the quadratic formula when we're talking about discriminants is we are only looking at these this highlighted thing right here, which is b squared minus 4ac, which is also known as the discriminant. Now, on the odd occasion, you guys will see in some of the books, they tend to use the symbol of a triangle, which represents discriminant as well. You know, maths, we always like to make things a little bit more tricky. Rahul, the quadratic formula is actually from a quadratic equation. So imagine if you have like, this is the general equation of a quadratic equation. And to find out what x is, you just got to rearrange. When you rearrange and complete the square, you end up with that quadratic formula above. Anyway, going to the discriminants, there's 3 things that can happen to the discriminants, and this is something that I'd strongly recommend you guys to try and kind of remember, or just, yeah, you just got to keep that in the back of your artillery at all times. So what we have got is, let me just better. So we've actually got 3 things that we need to consider when we're dealing with discriminants. That is when the discriminant is a positive number, when the discriminant is 0, and when the discriminant is actually negative. So imagine it like this. So if you take a parabola and you could do it on the x-axis, or if you could have like another line going through as well, it doesn't really matter. I'm going to choose the x-axis in this case today. Just trying to kind of like do different things, I guess. So when the discriminant is actually positive, that means the parabola is going to end up cutting the x-axis at 2 points. When the discriminant is 0, the parabola will cut the x-axis at 1 point, and when the discriminant is negative, the parabola will not cut the x-axis at all. Now, let's say we don't have an x-axis, but we have a straight line that's going through, then it could look like this. So if the discriminant is positive, then you could have a line going through like this, and what you have is 2 points that the parabola is actually cutting through. Or if you have, when it equals to 0, you could have a straight line that's kind of like going on an angle, but just touching it once. And then finally, when the discriminant is negative, that generally means that that line is probably not touching the parabola at all. So in reality, what we have is we've actually got these 3 situations. And a couple of things that are worth noting about these 3 situations is just this, that when you have discriminant, in this it's positive, so it's going to be greater than 0. In this case, it is equal to 0. And in the final case, when it's not touching anything, it's going to be less than 0. Sometimes you'll see things like 2 solutions, and then for this case you have 1 solution, and in the final case, when they don't touch each other, you've actually got no solution. Sometimes if it goes on the x-axis, you might see like 2 roots, 1 root, and no roots. So for you guys, I'd strongly recommend you guys to kind of like maybe take like a mental snapshot of this, and because this is just something that just keeps coming back again and again. I am trying to think about last year's exam paper, and I know I did it very, very quickly. Let me just have a quick look at the exam paper. Was there any discriminants last year that I thought of? Sorry guys, just having a quick look at last year's paper. Was there no discriminant questions? Thought there was something. They got a version of it. Bloody annoying though. Yeah, but anyway. Well, hopefully we don't get a paper that crazy like we did last time. Yeah, Oliver, these videos get uploaded about 10 minutes after I finish the stream, man, so you can always come back and watch it anytime. That's all right. We'll just kind of go through these questions anyway. Does anybody have any questions on what we have kind of done so far? Just with the ideas, and then we can start doing some questions. No, I have not done it yet, John, so just kind of got sidetracked with tutorials. Otherwise, I'd have usually got that out. Anyway, can we move on to some questions? Or you guys still, you can always just go to the link and you'll see if you click on the link that I posted right at the start of the chat, then you should be all good to go. I've got no idea what that is. Cool, let's actually go with some of these questions, guys. So here is kind of like your first kind of question. So I'm going to leave it up here for you guys, and so remember that in this case, it's not actually crossing the x-axis. So because it's not crossing the x-axis, I'm just going to give you guys a bit of a hint here. So that's what you're trying to do. So what you're trying to do is you're trying to figure out what ABC is, calculate your discriminant, and you should be able to prove what was I going to say? Yeah, you should be able to kind of prove that the discriminant is actually less than 0. So have a go at that. I have no idea, Jules. I give up, man. All right, guys, I'm going to go through question one. I mean, that was like a nice starting question for going through discriminants. One thing that I would recommend you guys is, I know you guys have your graphics calculator, so you could always just go into graphs and put that in graphs just to see what the graph looks like. So x squared plus 3x plus 7, and just click on draw. And right now I can't see my graph. That's because it's probably, just need to zoom out a little bit. Yeah, there it is. This is ridiculous technology, but this is what we have to use. So there is the parabola. And as you can see, it is not crossing the x-axis, but we've got to actually prove it algebraically. So what we're going to do is we're going to actually write down, and this is another thing that I tend to ask my students to do as well. So I actually write down ax squared plus bx plus c first, and underneath it I write down my actual equation that was given. So in this case it was x squared plus 3x plus 7. Once that's done, also remember that x squared has actually got a 1 in front of it, so the coefficient of x squared is actually 1. So our next step is writing down these three values. So a is equal to 1, b is equal to 3, and c is equal to 7. So once we do that, we work out what the discriminant is, which is b squared minus 4ac. So we've got 3 squared minus 4 multiplied by 1 multiplied by 7. So we've got 9 minus 28, which gives us negative 19. Now, it's basically at this point you've got the discriminant, which is actually negative 19. So because it's negative 19, you kind of you have to kind of say that b squared minus 4ac is less than 0, therefore does not cross the x-axis. So a nice kind of like achieved question to start. It's just trying to find the discriminant, and then trying to actually show that when it's actually a negative value, that if it's a negative value, that means it has no roots or solutions. If you're okay with that, just let me know to move on to the next question. So, okay, so moving on to the next question. Cool. So next question, what we have is slightly changing it up now. I did make a typo here. Give me a second. That should be P. Also, I just want to show you guys real quickly. I don't think I need to show you guys, but let me just have a quick look at that. So this was question 1 right there. So, I mean, we just worked out the discriminant, but that's the same thing as this. You can kind of see the minimum point is at minus 1.5, so it's not really going to cross the x-axis at all. So that's question 1. Then we're going to go to question 2. Now, question 2, what I'm going to show you guys first is what this equation actually looks like first. All right. So what I'm going to do is I'm going to move this out to 0 for now. I will give you guys a chance to have a go at the question, but just want to show you guys what the question actually is asking for. Because if you go back to the question actually says find the range of values of the constant p so that the equation does not cross the x-axis. All right. So right now, if I put this as my graph, x squared plus bx plus 16, as you can see, it's right up there. But as p changes, at some point it's going to have like 2 values. All right. So let's go back to the question. And in here, you guys actually need to work out how to calculate P. So, and I know this, I've kind of thrown you guys a little bit in the deep end here, but I'll actually walk you through this question, and then after that, if you feel like you're comfortable, you got the hang of it, then I can give you another one, or we can actually move on. So the first thing to recognize is this part right here. It does not cross the x-axis, which means our discriminant, if you go back to our original discriminant diagram, this is the one that we're looking at, because it doesn't actually cross the x-axis. So because it doesn't cross the x-axis, we know that the discriminant has to be less than 0. So what we've got is we've got b squared minus 4ac is less than 0. So that's the first thing that we need to actually understand. All right. So the next thing is we're going to have to write down, try and figure out what our ABC values are. So we're actually going to go ax squared plus px plus c, not px, bx. And if we look at our original question, it is x squared plus px plus 16. So from here, we can see that the a value is going to be 1, our b value is going to be p, and our c value is going to be 16. So we're going to write all of that down. So a is 1, b is p, c is 16. So sometimes, and I know that they did do this in the past papers, where if you set up this equation and put the right, substitute b squared minus 4ac and put it less than 0, you can actually end up getting an achieve just for that. And I don't know if they're still doing that, but it's something that's always worth knowing. So in this case, because b squared minus 4ac is less than 0, we're going to write this as p squared minus 4 times 1 times c, which is 16, which is less than 0. So in other words, what we've got here is p squared minus 64 is less than 0. Now this is where you guys need to remember. This is stuff that we did last year in level 1 algebra, when you had a quadratic inequation. All right, so quadratic inequation is, this is the one where you got to find the 2 points and then get the correct zones. So what we're going to have to do is, yeah, it comes back. I'm telling you guys, the quadratic inequality is always going to come back, even at level 3. So it is something that that's going to constantly keep coming back. And if it's something that you find it a bit challenging, then go back and have a look at my last year's revision tutorials. Then you should be pretty much good to go. Yeah, I see that you guys are getting the values correct, but remember, in this particular case, it's the zones that we have to get. All right. Yeah, thank you, Makis. I think that's what I was looking for. But basically, what we've got here is we do it like normal. All right. So we put down minus p squared minus 64 is equal to 0, which means we got p minus 8, p plus 8 equals to 0. So we can say that p equals negative 8 and positive 8. But the problem is, if you go back to the question, it actually says the range of values. All right. So what does that actually mean? We have to go back to this particular graph, and we're going to draw that real quickly. All right, because we know it's a parabola because of the p squared, and it's a positive p squared, so it's going to look like a positive parabola. We also know that it has 2 intercepts, one at minus 8 and the other one at positive 8, and I got those values from there. Now we're also looking for, when is this graph less than 0? If it's less than 0, it is going to be between these 2 values. So we have to write our final answer as negative 8 less than p less than positive 8. All right, because p is actually between minus 8 and positive 8. Now, bear with me for a second because I'm going to switch screens and I'm going to show you guys what it means to do it on Desmos itself. So on Desmos, if you guys have a look, when I make P is equal to, like right now, it's not crossing the x-axis. All right. So, and I think what we're trying to say is that it's, if you go back to the original thing, so the range of values for P so that this equation doesn't cross the x-axis. So if the P is between -8 and +8, then it will not cross the x-axis. So if you guys have a look here, so right now, if I go to 8, where is it? Where is it? There we go. At 8, it's actually touching the x-axis. But if I go above 8, then it's actually going to still be touching that x-axis. But if I go to -8, as you can see, right, between 8 and -8, it's not actually touching the x-axis at all. But the moment it comes to -8, it will touch the x-axis. As you can see, it's going to touch the x-axis there. All right. So it's a really kind of like, I'm just trying to show you guys what you're actually trying to calculate with these questions. Because sometimes you're looking, you've got two parabolas here, but the first parabola, this is the original parabola you're dealing with, but that p squared minus 64, this parabola here is something that we're trying to use to find out the range. That's the whole purpose behind this. Yeah, so any questions at that point? Do you guys want another question, or do you feel like we're good to go and we can just move on? Cool, that's good to go then. So we shall go to the next question. Just coming back, can this be done with another value like A or C? Not so much with A, Leo, because remember that when I adjust the value of A in a parabola, it just makes the parabola go bigger or like wider or skinnier. C, definitely we can do with C. Do you guys want to try one with where it's the constant? We can do something like that. The C one is going to be straightforward because it's not, it's a single constant. So, but that's fine. All right, I'll see if I can just create a quick one. Where is, give me a second. I just need to write up the question just to see if it actually works. So what do we got? X squared. Just give me a second, guys. Just trying to come up with the question. All right, so I'm going to try and do the same question, but this time I'm going to try and change it all. Whoa, 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 whoa. Okay, so instead of that being, let's try this one. Actually, wait, I'm just going to change that question. Give me 1 second. S, so the X. A slightly different variety of that question. S greater than 4. Yeah, I did change the question around, Salty, so I don't know if you picked that up or not. All right, so because I said that, it's interesting. We got a couple of versions of this question. All right, let's try it out. This is 4. So because it's going to always cross the x-axis, we know that b squared minus 4ac. And I guess this was a really interesting point, like would you actually use less than or equal to 0, or less than, just less than 0? And I think it's up for debate, because when it touches the x-axis, you know that the discriminant is actually equal to 0. But when it crosses the x-axis, we can say that it's less than 0. And I guess it's always up to interpretation. Maybe I just wrote a bad question, and that's why I don't write exam questions. So in this case, I might just go with what you guys have actually got of less than or equal to 0. And again, like I said, this is up for debate. But right now, I'm just more curious on getting this working out for this. All right. So remember that we've got ax squared plus bx plus c. So we've got x squared plus 4x plus s. So our a is equal to 1, b is equal to 4, and c is equal to s. So we've got 4 squared minus 4 times 1 multiplied by c, which happens to be s, and it's less than or equal to 0. So we've got 16 minus 4s is less than or equal to 0. Negative 4s is less than or equal to 0. Take away 16 is minus 16. S is minus 16. And because I am dividing by a negative number, I need to change the sign, which means S has to be greater than or equal to positive 4. Let me just check that. Does that actually work out? Something doesn't feel right in this question. What have I made a mistake with? Made a mistake in the first part of the question. That's why. Because if I'm actually looking for a positive because if it crosses the x-axis, then I'm going to have like two roots, which means it has to be positive or equal to 0. Sorry, that was my mistake. Silly mistake. That's all right. I knew something wasn't right when I did that question. There we go. Yeah, thank you, Beckhamster. Yeah, I was slow day at the office. Yeah, so we got to get s is less than or equal to 4. Now, if you guys have a look at how I did this on Desmos as well, so you can have a look. So that's my graph that I'm working with. And what I've got is, you'll notice that when I get to 4, it's crossing it's touching the x-axis, but then if it's less than 4, it's going to always cross the x-axis. But if it's actually above 4, then it's definitely not crossing the x-axis. Yeah, Rahul, I'd love to have a debate about this one, but I don't know, man. I actually think my original thought was this, because if it's always going to cross, because if it's actually crossing the x-axis, that means it has to have greater than. That's what my original thinking was, and I'm actually going to go back to my original thinking. I don't know. I wouldn't put it equal to, because it equal to is not crossing it, but it's just touching it. Yeah, it's like standing in the middle of a pedestrian crossing. You haven't really fully crossed it, but just standing there. Anyway, let's. If equals, then only touch the. Yeah, that's right, Leo. If it's equals, then it's only touching the x-axis. Yeah, and also for repeated root, which we will get to. Cool. Let's go to number 3, and why don't you guys have a go at this? I'm not sure, Leo, because that would have been probably, that question would have been a merit question at least. But yeah, I guess I should have worded the question better. It was just in a rush that I made that question and I didn't think about the consequences. Anyway, going to question number 3, my suggestion for you guys to try and do this question is put both of the equations equal to each other, expand, rearrange, and then figure out what the discriminant is. So have a go. I'm going to give you guys about 2 minutes for this because just need a bit of a water break. So yeah, so time right now is 8:33. We'll go through this at 8:35. Cool, guys. Looks like you're pretty much on track there. So let me try and work through this. So remember, just putting the discriminant as -12 is not enough. You'll have to actually write an explanation that saying that, yeah, like if discriminant is less than 0, then there's no real roots, or it doesn't actually intersect as well. So to do this, we're going to put both of these equations equal to each other. So we've got x plus 2 squared minus 1 equals to 2x minus 1. So we're going to expand the brackets here. So we got x plus 2 times x plus 2 minus 1. I might as well bring this 2x minus 1 to this side because it's going to become minus 2x plus 1, and all of that is equal to 0. So expanding the brackets, I've got x squared plus 4x plus 4 minus 1 minus 2x plus 1 equals to 0. What have I got here? I've got x squared plus 2x plus 4 equals to 0. So a is equal to 1, b is equal to 2, c is equal to 4. So find out what b squared minus 4ac is. So I've got 2 squared minus 4 times 1 times 4, which is 4 minus 16, which gives me -12. So I just write this down. Discriminant is -12. Just a little statement. As discriminant is less than 0, therefore no. You can write no solutions as well, because that just means that there is no solutions or intersection points. Either way, that statement is necessary. Straightforward, move on. You'll get to that next year. You will get to that next year. All right, let's go to question number 4, guys, because I think that was all right. Just to quickly show you guys question number 3 there. Just wanted to show you guys very quickly. So this was question 3. As you can see, it's not really touching the x. They're not really touching each other. So that means, yeah, we pretty much on par with that. Would that be a merit question? Let me just think back to it. In systems of equations, yes. Equal to each other. Yeah, I think it'll be under merit question. Possibly like the borderline achieved merit. Yes, Rahul, it does. So that's pretty much what systems of equations standard is. No, Benny Poo, you can't do that. Because theoretically you can factorize it in level 3, but not yet. So that's what Marquise was talking about earlier with the imaginary roots. That's something you'll learn in level 3. All right, guys, our next question is this. So kind of level up from question 3. Exactly the similar kind of idea. But yeah, so that's what we're looking for. We're looking for the value of k so that we can actually figure out what p is. So again, I'm going to give you guys like another few more, like maybe about 4 to 5 minutes on this one, because this is a little bit longer, because this one would be an excellence, similar to an excellence question, because there's like quite a few things that you have to do. Back in the day, it was excellence. When I say back in the day, 2 years ago, I don't know what it is now. Yeah, I kind of agree with what Key said there. It was not um, like it was not fun. AL, you do have calculators for this paper. You're allowed a graphics calculator for this exam. Yeah, man. You're allowed a calculator for level 2 algebra and level 2 calculus. That's why I've got the graphics calculator on the side there, just to show you guys how to do some of these stuff. Because Rahel, it's actually touching at one of the points, and it's only 1 point. We've got to determine the constant p. I'm sure I made this question so that it only touches 1 point. Let me just double check. This is question 4, right? Yeah, it only definitely touches it at 1 point. Like in some situations, the parabola can touch it once at 2 different points, but this particular question, I've done it so that it only does it at 1 point. ML, I think this whole tutorial that's what we're doing for. We're just doing discriminant stuff, so we're just trying to do like different types of discriminant questions. So if you've just kind of joined in now, I would say go to the start of the tutorial after it's finished. It should be ready by like 9:15 and just watch what we're doing. Do you guys want me to go through the question yet, or do you guys need a bit more time? Half and 1.25. Okay, let me go have a look. What was the K value you got, Makis? Oh, Makise, I'm sorry, I got the getting your name wrong. Benipu, what was the K value that you got? Find K first, and then find P after that. Yes, Johnny, you can. Once I stop the stream, it should be up and ready to go in about 5 minutes. Oh, you got 6 as K. Oh, we're getting a lot of different K values. Cool, guys. We're getting a lot of good little mistakes, which means that you guys are actually going through the process. That's really awesome. So when I go through the question, you guys can have a look at where you might have made a slight mistake. All right. From what I can see so far, there's a lot of positive things that are happening there. So what are we going to do in this case? We're going to put both of these equations equal to each other. So we've got x squared minus 4x plus 3 equals to negative x squared minus 2x plus k. Now remember that we do have to put them both equal to each other because we're trying to figure out where it's going to meet at that point, right? Because both of these parabolas touch each other at the point P. So basically, a quick visual guide is this. This is a positive x squared, which means the parabola looks like this. This is a negative x squared, which means the parabola could, and basically it might look something like this, where that point right there is P. That's one option. Or it could look like this, where it's like kind of like touching on this side. So we don't really know, but we don't really care what it looks like. But as long as we know, that's what the question's actually asking us, right? It's asking us to figure out where that P value, what's the point of P, the coordinates of P. So we're going to put both of these equations to equal to each other, and we're going to rearrange it. So we got x squared minus 4x plus 3 equals to 0, because I'm going to bring everything on to the from the right hand side to the left hand side. So I'm going to get plus x squared plus 2x and minus k. So simplifying this, I'm going to get 2x squared minus 2x plus 3 minus k is equal to 0. All right, what I'm also going to do is I'm going to start putting some line numbers here. So if people do feel like, actually, I don't know how he got that, just yell out whichever line that you don't understand, and I'm happy to kind of explain it, or somebody in chat could just kind of mention it as well. Cool. So once I do this, my next step is to go ax squared plus bx plus c equals to 0. So in this case, my a value happens to be 2, b happens to be minus 2, and then 3 minus k, which is 3 minus k, ends up being your c value. All right, so once that's clear, we also know that it's meeting each other at one point. So we're going to get b squared minus 4ac is equal to 0. So that's our step 4 right there. And we're going to substitute all of our values. So we've got negative 2 squared minus 4 times 2. And then c is equal to 3 minus k. All of that is equal to 0. So we're going to expand this. So we got negative 2 squared is 4 minus 8 times 3 minus k equals to 0. So we got 4 minus 24 plus 8k is equal to 0. So what do we have? 24, we've got negative 20 plus 8k is equal to 0. 8k is equal to positive 20, which means k is equal to 20 over 8, which gives us 5 over 4, or 2.5. No, 5 over 2 or 2.5, is it? Yeah. So k should be 2.5. Now, because we've been asked to figure out what the x and y value is, how do we do this? So because we now need to figure out what the x and y value is, right? Now we've got what k is. So we're literally going to take this k and substitute it in this line here to figure out what the x value is. So in other words, let me just, give me a second. That's fine. So we're going to write that down. So we've got 2x squared minus 2x plus 3 minus k, which happens to be 2.5, and that's equal to 0. I'm just wondering, is there another way of doing this? Nope, so far that is it. So here I've got 2x squared minus 2x minus, no, plus 0.5 equals to 0. At this point, I'm just lazy at the moment, so I'm going to go straight into my calculator. Yes, Rahul, that's the possible. So go to polynomial, degree 2, and what have we got? We've got 2, no, minus 2, and 0.5. So as you guys can see, x is actually equal to a half, and you can see the little times 2 there. The times 2 there is telling me that it's a repeated root, so that means it's happening twice. So then in this case, we can actually say x is equal to 0.5. Then we've got to figure out what y is. So y is equal to x squared minus 4x plus 3. You could use either equation, it doesn't really matter. So 0.5 squared minus 4 times 0.5 plus 3, whatever that gives me. So 0.5 squared minus 4 times 0.5 plus 3 gives me 1.25. So the coordinates of P is 0.5 and 1.25. So guys, I just wanted to show you guys what it looks like on Desmos, and I'm going to come back to this working out. So if you guys have a look at it, what I've done is I've drawn x squared minus 4x plus 3. Where is my... I've drawn x squared minus 4x plus 3. And then when I put k equals to 2.5, you can kind of see that it's actually it's touching at that point 0.5 and 1.25 and 0.5. Because anything else, if k is any other value, it's either going to miss it completely, or it's going to have like 2 points where it's actually cutting it at. Yes, you can, Ashwin. You can put it in the other equation as well. Liam, you are definitely allowed calculators in this exam. I'm 100% sure on this. I can even show you the document that says you're actually allowed to take this calculator in for a level 2 exam. It's just level 1 you're not allowed to take the exam. It's only for level 1 MCAT that you're not allowed to take the graphics calculator, but every other exam you're allowed to. Sorry, I'm going to go back to my notes. Kind of left you guys hanging there. Right, do you guys have any questions here? I'll put up some line numbers. So if you do have any questions, you can just kind of yell out at the line number. Rishi, for the quadratic equation, if you're using a calculator, you don't really need to show the working. You can just put it straight in the calculator, and so basically just go straight to line 14, man. From line 13 to line 14, you don't really need to show working. You can just show the work, do it in the graphics calculator. Eileen, that's what I did in the graphics calculator. So all I did was to go from line 13 to line 14. I just clicked on menu, went to equation, clicked on polynomial, which is F2. Degree is like x squared, so it's a degree 2, and then put those values. So A value is 2, B is negative 2, and C is 0.5. Click enter, and it's going to tell me that it's 0.5. That little times 2 is telling me that there's 2. It's a repeated solution. So that's how I get the 0.5 for line 14. So basically from line 13 to line 14, I just used the graphics calculator for it. Any other questions, guys, before we move on? Ah, okay. So remember how I talked about this point right here, which happens to be the p-value, right? Now it's got a x and a y coordinate. Basically, what I did was like when I solved x equals to 0.5, that actually gave me the x coordinate for p. Next, I needed to figure out what the y coordinate was. And so to figure out what the y coordinate is, I needed to come back here, put one of those equations, which was y equals to x squared minus 4x plus 3, and then I needed to substitute wherever x was with 0.5 to try and figure out what the y value is. And once I got the y value, that's what I ended up putting here, and the x value, what I solved, ended up coming here. Now, Eileen, I could have used either one of those equations that was given to me. So to give you another example, I could have used the other equation, which was minus x squared minus 2x plus k. Yeah, I'm just showing you, you could have used that one as well. So now k was equal to 2.5. So watch what happens. I should get the same exact answer if I do it this way as well. So 0.5 squared minus 2 times 0.5, and k was 2.5. So if I go back to the calculator and just plug in those values, I should end up with the same answer. So I've got negative 0.5 squared minus 2 times 0.5 plus 2.5, and that also gives me the same answer, which is 1.25. So it doesn't matter which equation you use, you are still going to get the same y value. All right, guys, we're going to do one last question. I hope that kind of helped you out, Eileen. Oh, come on. Ooh, there we go. So I'm assuming we can move on. So this is our last question for the night, guys. And I am going to, ooh, wow, 8:58, yeah. Now we're going to try and do this real quickly, guys. So I'm going to try and do this question in another minute. So you guys have a go at this question. The trick is what I talked about before. This one has repeated roots. one day I really need to actually put a Google map up and just get you guys to all put a pin on it to show you guys where you guys are from. That'd be a pretty cool thing to do. Just interested just to see how far people from New Zealand are actually attending these tutorials and using my channel. All right, you guys got two answers there, so we might as well get going. So because equation has repeated roots, which is the same thing as saying one solution. So we could actually straight away say that b squared minus 4ac equals to 0. And what we're going to do is kind of write everything down. So a equals to 1, b equals to 3m plus 1, c is equal to m plus 3. So just to reiterate there, a is 1, b is 3m plus 1, and c is m plus 3. So once we have that, we're going to kind of go b squared minus 4ac. So 3m plus 1 squared minus 4 times a times c, which is m plus 3. And all of that is equal to 0. So expand the brackets first. So we've got 3m plus 1 times 3m plus 1 minus 4 times m plus 3. And all of that equals to 0. So expanding the brackets, we're going to get 9m squared, 3m and 3m is 6m, plus 1, minus 4m, minus 4 times 3 is minus 12. All of that is equal to 0. So simplifying this, we're going to get 9m squared plus 2m. What else we've got? Minus 11 equals to 0. Now, at this point, again, I am absolutely lazy when it comes to quadratic equations, especially when we can use the graphics calculator. So I'm going to go into my polynomial 2 degrees. I've got 9, 2, and minus 11. And there are my two answers. So I can actually say that m is equal to 1. Now, I know that you guys can see that negative 1.22. Particularly, I'm looking at Rishi, you put that negative 1.22. What you can also do is if you go down on your calculator and just go and highlight the negative 1.22, then you should actually get the fraction of that answer, which is negative 11 over 9. So it's a really good idea to, if you ever see like, oh, does that work too? Yeah, see, you've got to click on that thing to actually make it go from fraction to decimal. So you go down to negative 1.222, and click on, yeah, if you click on fraction to decimal, it should show you negative 11 over 9. Cool, so that was a nice kind of simple one to finish off the session. Yeah, guys, that's basically it. What did I wanted to show you guys in Desmos for question 5? Is it even worth showing it? So question 5 was this right here. I think we had two values, right? So negative, so we had it at 1. So when it equals to 1, it touches the x-axis, and then negative 11 over 9, which is around at 1.22, I think you guys said it was. Let's try that. Yeah, it's close enough. There we go. It's touching it there. Okay. How come I disregarded the x value to the right of 3m plus 1? Ah, that's because the only thing that I'm focusing on are just the coefficients. And I guess my mistake is I should have highlighted the number in front of x squared, which is x is 1. Sorry, the coefficient of x squared is 1. So remember whenever you're using discriminant rules with quadratic equations, your a, b, c does not have any x's at all. So I'm just taking the coefficients of those values. No, I didn't need to expand it, Eileen, because if I expanded it, I still have to factorize it to get the coefficient of x. So remember, what I mean by coefficient of x is the value in front of x. So I just want the value. So say, for example, if I have something like this, 3x squared plus 4x minus 7, then ax squared plus bx plus c. Think. So then the only thing that we care about is the values only. That's all that we care about. So in this case, we're going to get a is equal to 3, b is equal to 4, and then c equals minus 7. So if we were to work out discriminant, we don't really care about the x at all. So it's 4 squared minus 4 times 3 times negative 7. Yeah, exactly, Eileen. That's what it is. What if m was not a constant? Then that's a completely different thing. Liam, just look up my name, man. You'll find it. It's just I'm in a terrible state. What if m was not a constant? No, it has to be a constant. I mean, like you're trying to find the range of values, right? So it's got to be some sort of value. It can't just be like a random letter. Level 1 MCAT, what are we doing? I think it's coming back on Sunday, I believe. All right, guys, gone well and truly above the time that I was supposed to go. I'm going to wrap things up here. I will catch you next time. I think I've got the level 1 and level 3s next. Yeah. Have a good one and stay safe. And I will catch up with you guys next time. As usual, I hang around in the chat, guys, for a while. But apart from that, see you next time.